in this presentation, we are going to focus on, especially on the real-time global ionospheric maps, but we are going to mention other benefits which are going on in space weather monitoring, precise farming, very briefly. Some details will be given in another talk this afternoon about space weather monitoring. So, well, it is well known the benefits, the new doors which are being opened by so many GNSS data streams available through IES real-time facility. And in particular, we are going to mention briefly about the space weather. Some of these applications we were commenting yesterday after the splinter meeting of the Ionospheric Working Group that nobody knows maybe in 10 years ahead how many new applications can be generated that we are not thinking now, thanks to this availability in an open way. In particular, for instance, one mention that will be later on developed is the detection and also the measurement of the energy or the energy of the sun during solar flares, for instance. And of course, in real time, there are we can monitor, and we are doing all the different centers the activity of ionospheric waves, which are very affecting a lot to the precise position because are non-linear, and also scintillation proxies and so on. And this afternoon, Alberto García Rigo will provide more details on some of these points. And regarding precise farming, is another example that we know closely in the context of one European project. For instance, in Southern Europe, there is a collocation between higher ionospheric modeling error, sparsity of ground-based networks, and also less economical funding. So joining not only the open real-time products from IES data, also open software receivers, we can do the things in a best way, hopefully. So going to the real-time GIMS, this is something quick, very connected with the like seems to be a seamless next step regarding to the Ionospheric Working Group products and activity since 1998, and basically. We are going to focus on some news regarding to the last workshop, IES workshop in Sydney, more or less 1.5 years ago. And these points are the first, just a very brief summary of the recent comparisons on some actual real-time VTEC models which are running. This was presented in the Bacon Satellite Symposium last summer. And also the results of one questionnaire analysis on analysis centers recently done, and also some points which we must to take into account, like how to perform the combinations in real time. So we have developed some thoughts, some ideas that should be checked soon, hopefully soon, to be able to be efficient in real time, to generate an accurate, not only with redundancy, integrity, but also accuracy, a combined product in real time. Finally, the apparent limitation of the present RTCM format. We have explored a bit which is the error lost actually in this conversion, and some recommendations arise from that. Well, I suggest to focus on the red arrow that you are seeing here is one assessment during about 2 weeks, more or less, during 2016, of the error of different global ionospheric models. You can focus on the right hand plot, which represents the relative error of the at global scale of the VTEC compared with the VTEC directly measured by JSON2, by the altimeter, dual frequency altimeter over the oceans. So just to very quick comment, there are two families of results. We are comparing the results of the available real-time from, for instance, from GNEST in in magenta, from Chinese Academy of Science in green, from UPC in blue, in light blue, and other DGFA from Munich and other and the combined IGS products in different colors. So there are two families. The real-time family is the upper. Of course, we are still. This is a challenging and new way of doing the things in the ionosphere, global scale, and interpolation is still a very big challenge in real time, particularly. But okay, the things are moving on. Second complementing validation, the first was done in vertical. This was done in slant using 35 global distributed stations which have not been taking part in the computations. So again, we get qualitatively similar result. We have two family of results between the real time for this almost 2 weeks analyzed in 2016. They were actually generated in real time, not emulated in real time. They were generated actually in real time. And the post-processing one are at the bottom, or near real time are at the bottom. Well, we have there was a recent paper where we have compared this consistency of both methodologies, vertical and slant, have been also studied in deep detail in a recent paper. So the second point that we have focused is in the questionnaire. This was done in the context of the RTIM working group of the IAG, and different aspects were, thank you very much, many of you or some of you here in the audience have been contributing, among other people. This was led by this initiative by Alberto García Rigo and by David Roma Doyase. And I want to focus mainly on, for instance, on the formats. IONEX and RTCM was the two formats that was answered by all the centers providing inputs, and also for the time being we are using the only available RTCM format message. Sorry, as was commented before in a spherical harmonics expansion terms. Also, we have got recently feedback. We have required feedback for this presentation, and I'm glad to tell that as there are at least 3 centers providing actual real-time GIMS. Of course, Kenes is doing this for a long time. Also doing using the RTCM, as is very well known and was before commented in some of the presentations. And also Wuhan University is doing that, but using IONEX format in the same way that in my research group, UPC on SAT. Chinese Academy of Science is very interested, and also testing the stability of the software and accuracy. And RRCAN is interested to join in the future, doing presently in real time. So there are activity, a new activity going on. Well, I prefer to show this picture, which is easier to explain. Presently, the weighting scheme for combining GIMS is based on a very simple direct measurement of the slant TC variation from the carrier phase combination, the geometry-free carrier phase combination. And basically, there are presently a number of about 16, if I remember well, worldwide distributed receivers, and this variation is observed, which is observed very precisely with a precision better than 1/10 of TC unit, around less than 1 centimeter. Is the RMS versus the prediction of the model is used to generate the weights for the present combination. This has been done for almost 20 years now. So how to extend this weighting for real time? So some thoughts about are summarized in this table. Basically, the first row is about the self-consistent. Is the way that we are doing right now. We call self-consistency. This means that we take we we make the difference between rays, between observations at the same elevation. So the observations are at different times and different piece points, different spatial places, but they share the same elevation. So this difference can be easily removed, the ambiguity, and after correcting the wind-up, it's a small term, you can map to the vertical, and you can get ideally a weight in vertical, assuming that the mapping function at 450 kilometers height is good enough. And so this is one of the ways. And the other way is doing as we are doing for some analysis, taking as reference the highest elevation rate is the B strategy. But in this way, the highest elevation rate is typically the one with lower errors in mapping in particular. So there are some pros and cons. I am not going to go into details, but just to show you other possibilities. For instance, in real time, if we want to apply the self-consistency, we have to wait for the second part of the arc. We have to wait of having observations with the same elevation. So this means that during the first part of the observations, we will not be able to provide a weight. So we will reduce the weights will be reduced to the half. Let's say in this way. So there are other possibilities, which is taking the first observation as reference, but this is, so you have full availability, but the first observation used to be quite bad from the point of view of the modeling, because the mapping problems are important. So anyway, finally, hybrid approach seems to be a good approach to do between the C and A. So this is something to be tested actually with in the incoming months. 1 minute. Okay. So so let's go to the last point, which is the spherical harmonics. Potential limitations of the present global format. I'm glad to list in the first presentation that there are augmentation ways for increasing the accuracy of the ionospheric models. This was a very simple exercise. We did a forward-backward transformation from the IONX gridding format to spherical harmonics in different orders from forward and backward, and we get important errors, of course, depending on the degree, but that strongly suggest to use a degree larger than that degree, the maximum degree, which is supposed to be a low now, if we are not wrong, in RTIM message, which is 16. So in this regard, we can say that the availability of the data streams, finally, in the conclusions, is opening new applications in space weather, practical applications like precise farming, and the news regarding to the last IGS meeting shows the high activity and maybe that we might be in the right way, in the right position, the right time, the right position to start making combination of the real-time GIMS and maybe joining other centers. But it's important to be aware about the potential limitations of the present message and the evolution of the message to avoid this loss of accuracy just for formats considerations. So thanks so much.